Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, salatu wassalam ala rasulillah wa ala alihi wa ashabi ajma'in, amma ba'd. Grade 10 students, we are continuing the lesson angles in circle. The second theory, it belongs to angles in the same segment. Okay, before go to the theory, we studied earlier the area bounded with two radius. The area bounded with two radius, area covered with two radius, you can call as minor sector. The larger portion called as major sector. So considering AB arc, the arc AB minor arc, and considering AB major arc, how can they form angle? Likewise, the radius dividing the circle into two portions. If the radius divides the circle, we called as sector. The name called as sector. So what is segment means? We already discussed AB. What is the name called for AB? So AB is connected 2 points from the circumference. If 2 points from the circumference of the circle connected, AB called as chord. So a chord can also divide a circle into two portions. The smaller portion we called as minor segment. So when radius divides a circle, we called as sector. When chord divides a circle, we call the portions as segment. Okay, the larger part is major segment. So angles in the same segment. So what is the meaning of segment? You get the point. Same segment means all the angles are in major segment, or all the angles are in minor segment. Okay, we'll go to the theory. So earlier in the first theory we discussed who creates angle. The arc is creating angle. For the second part also, same way the arc is creating angle. So we'll consider a minor arc AB. We consider a minor arc AB. Okay, if you consider the AB arc, so the arc can subtend angles where it can subtend angle at the center, and it can subtend angle at the circumference. So now we are going to discuss about the angle subtended at the circumference, remaining part of the circle. Okay, so we make a point on the remaining part C, another point D. Okay, so if we connect this point C to A and B, so the angle subtended at C is theta. The angle subtended theta by AB arc. Okay, and also if you connect D to the ending of the arc, so ADB theta 2, so theta 1 will mark as theta 1. Theta 1 is also formed by the arc AB. Okay, what is the position? How can we say the position of the angle formed at the C and D? So how can we say the ACB angle's position and ADB angle's position? Here the center is not connected. For that reason we are going to connect the AB. We are going to connect the AB. So if we connect AB, so AB is a chord. AB is a chord. So the circle divides into two portions. The larger part, the upside of the AB is called as major segment. The small portion is called as minor segment. Major segment, minor segment. Okay. ACB, ADB both are one of the side of the chord. ACB and ADB are one of the side of the chord, which means ACB and ADB are on major segment. ACB and ADB are on major segment. Likewise, the first theory, AB arc is creating the angle, but the position of the subtended angle going to be changed as in the segment, same segment. Okay, so AB divides the circle major segment, minor segment. The subtended angle ACB and ADB are on the same segment, same side of AB. So ACD and ADB are on the same segment. So therefore we can say ACB equals to ADB, because if two or more angles on the same segment, those angles should be equal. Without equal angle, they cannot be on the same segment. Okay, so AB arc creating the angle, subtended the angle as the first theory, but the position of the angle subtended, angle formed, we called as it's in the segment. If all the angles are in same segment, all the angles are equal. So we checked how an minor arc create an angle. So minor arc create angles on major segment. If you look at the figure, minor arc can subtend angle on major segment. So C angle and D angle, ACB and ADB are on major segment. So those are in the same segment. So those angles are equal. Okay. Now we are going to consider about major arc. So major arc AB. If you consider this major arc AB, so where can AB major arc subtend angles? On the circumference. So we will mark 2 points as C and D. The remaining part is here. So AB major arc can subtend at C or D or anywhere else in the remaining portion. We selected 2 points. Okay. How we can form an angle? Connect point A and connect point B. Ending points connected to a particular point. So subtended angle. So we name it this angle theta. And connect B and A. So we name it this angle theta 1. Okay. So what is the position of ACB angle? Same name. And ADB angle. So how can we describe the position of ACB and ADB angle? Here they didn't mention any center. So we need to connect AB. So if you connect AB, AB is a chord. So this larger portion is major segment. This one called as major segment. Okay, so the small portion we called as minor segment. So ACB and ADB are on minor segment, same side of AB, same side of AB. In other word, same segment. In other word, in minor segment. So ACB and ADB are subtended angle at the minor segment. So those are in the same segment. So angles on the same segment are equal. Without equal angle, they cannot be exist on same segment. So the same angles in same segment means if two or more angles are on the major segment or minor segment, all those angles are equal. So that is our second theory. Okay, let's consider another figure. So we can have a minor arc AB. So we'll have a minor arc AB. So we are marking 3 points on the remaining part. So we're naming CDE. So if you connect the points with the arc, we know all the angles are subtended by same arc. Those angles are subtended by same arc. So theta 1, theta 2 and theta 3. So if you look at the figure, AB arc subtending angle ACB theta 1, then ADB theta 2 and AEB theta 3. All the angles subtended by same arc AB. Okay, now we are going to describe the position of created angle, the position of ACB and ADB and AEB. So to describe the position, we need to connect point A and B. If we connect A and B, so AB now divides the circle into two portions. So all these points are CDE, all these points are on same side of the AB chord. In other words, those are in major segment. Those are in major segment. All these points are in major segment. So therefore, we can call ACB, ADB and AEB are on same segment. So those are called as same segment angles. So AB arc can create angle on the major segment. All the angles are in major segment, so that's why we call same segment angle. If angles, two or more angles are on same segment, those angles should be equal. We'll discuss the theory, but I'm introducing the theory now. Okay, just get the idea. Okay, if we consider AB major arc, we are considering AB major arc, and we select 3 points as CDE. So if you consider the major arc AB, so it can form angle on the remaining part. So if you connect the ending point, you have the angles. Using the first theory, we are connecting the ending points. So this is the theta 1 This one is theta 2, the other one is theta 3. Okay, AB arc, AB major arc, subtending angle at CDE. So if you connect AB, so CDE points are on minor segment. In other words, CDE points are on same segment. So that's what we call ACB and ADB and AEB are angles in same segment, because those angles are on same side of AB on minor segment. So you can now identify what is the angle in same segment. So the theory is all the angles in same segment are equal. Why? So using the first theory we are going to prove it. Okay, we'll take a minor arc and the center is also here. So we'll subtend two angles. We subtend two angles. Okay, we'll subtend two angles C, and we'll subtend another angle here D. So this theta 1 and this theta 2, this is theta 2. So the center is named as O. So I'll connect the center with red. Okay, and I'll connect AB also. I'll connect AB also. So what about ACB? What can you say about ACB's position? ACB is on major segment. AB dividing circle, major segment. And what is the position of ADB? It is also in the major segment. So ACB, ADB are on same segment. Okay, if you connect the center to the ending of the arc AB, so what is the relationship between theta and AOB? Center is O. AOB, yes, AOB is, we can say with the first theory, AOB is 2 theta 1. AOB is 2 theta 1 because AB arc subtending angle center AOB, AB arc subtending angle at remaining part ACB. So it's double. So what about AOB considering theta 2? AOB arc subtend angle center AOB, that is AOB. AB arc subtending at D, it's theta 2. So same arc subtending angle. So relation between theta 2 and AOB, that's double the theta 2. So if you consider the first and second, the arc is same, the same arc creating angle. C and D are on same segment. The center angle created by the same arc is AB. AB arc is the arc creating center angle. So the magnitude of the center angle does not change. Why? Because AB arc is creating. So considering C and D angle, those are going to be equal. So that's why we say angles in same segment are equal. ACB and ADB are going to be equal angles. Okay, so we'll go for the formal proof and we'll discuss some examples. Okay students, draw this figure. AB minor arc creating angle. The center is marked as O. And also the AB chord is also connected. So first part, data. So write it. The points C, D and E. The points C, D and E lie on the circle. Of center O. Lie on the circle of center O. On the same side, of chord AB. On the same side of chord AB. Okay. To be proved that ACB equals to ADB equals to AEB. Those angles are equal. You need to prove those angles are equal. Okay. For we need a construction. Before going to the proof, we need a construction. Join OA, OB. So OA, the center must be connected. OA and OB. Okay, if you look at the figure, you have an arc AB subtending angle at the center. It's AOB. And same arc subtending angles on CDE. So we are going to write the first theory. AOB is equal to ACB. You can write the theory. Angle subtended at the center is twice the angle subtended at the remaining part of the circle by the same arc. Write the entire theory. So using that theory, we are going to write ADB and AEB. So the same reason. So if we are using same reason, we write a word similarly. AOB. So we'll mark at first statement. AOB is equal to ADB. We don't want to write the theory because we write it similarly. With the same reason, we are writing here. And the second statement is there. And another statement, AOB is equal to 2ACB. 2ADB. And AOB is equal to 2AEB. Same reason. So if you consider 1, 2, 3, all are AOB. So all are equal. 1 and 2 and 3 are equal. So ACB equals to ADB equals to AEB. The same segment angles are equal. That is our theory. So we can write the theory. The angles in the same segment of a circle are equal. So that's our second theory. We'll discuss some examples and you can do the exercise. Okay, before that, so we are considering minor arc. Can we apply this theory for major arc? So you have a figure to think. AB major arc. I am connecting the center angle O, and you have 2 points C and D. I am connecting those points also. So So using this same proof, you can check whether a major arc can subtend equal angle on same segment. So major arc, minor arc, both can subtend equal angles. You can check whether it is okay, this proof is okay with this figure also. Okay students, you have 3 example questions here. Copy the figures and we'll go for the questions. Okay, first example question, we have given a figure with unknown terms a and b. Find the magnitude of a and b. Okay, if you closely look at the figure, there are some angles subtended by same arc. If you consider this arc, name is not given, but for the explanation I'll give some names. A, B. So now you can see AB arc create an angle here and same arc create an angle here. So if you connect AB, imagine if you connect AB, so those angles are on same side of AB. If you connect it, those you don't want to connect it, you can think if we connect A and B, those are on major segment, same segment. So A and 27 are same segment angles because AB arc creates the angle. So A is equal to 27. The reason is angles in same segment. Angles in same segment. Okay. Likewise, if you rotate the figure, consider arc CD. So CD creates angle 20 and CD creates the same angle at A, because if you consider CD, 20 and B are same side of the chord CD. In other words, same segment. So B is 20, the same reason, same segment angle. Okay, go to the second example. Find the value of ABC. There are 3 unknown terms ABC. Okay, what is the position of A and B? So you need to go and find which arc create A and B. So if you consider angle A created by this arc and considering B, the same arc creating the angle. So if you join the point of the arc, B and A are on same side of the chord. That means same segment angle. So A equals B. You can say A equals B because same arc creating those angles. Okay. So then what else? Likewise 40 and C, you can examine the figure. 40 and C is same side of this arc and created by this arc 40 and C. So first we can easily find C, so not AB. So C is equal to 40, angles in same segment. So we have C 40 here and 85 is given. So considering this triangle, we can find B. So 40 plus 85 plus B is equal to 180, sum of interior. So B equal 180 minus 125. So that means that is 55. So already we discussed A is equal to B because same segment angle. So A is equal to 55 because angles in same segment. Okay, go for the third question. Find the value of A. an angle 94 is given, the entire angle is 94, and an isosceles triangle is given. Okay, what is the position of A? Which arc creates this A? The same arc creating this angle is A. So using the figure, we can mark this angle is also A. If this angle is A, with the given data, these sides are equal. So this angle is also A. The A angle is given here. So the same arc creating this angle is same arc creating this angle also. So those two angles are same segment of this chord. So if it is A, this is also A. Using the data given, the sides are equal. So if it is A, this angle is also A. So now we can have angles on a triangle. So 2A plus 94 is equal to 180. So 2A is equal to 17 minus 9, that's 86. 2A. So A equal 43. So likewise, we can use the theory angles in the same segment, and you can complete the exercise 31.4 and 31.5 related to angles in the same segment.